Hello everyone, myself Dr. Sriparna Saha, and on my YouTube channel we used to discuss about different topics related to some theoretical ones and for the coding purpose as well. Today we are going to talk about the beginners topic or the lectures on artificial intelligence. In that artificial intelligence domain, we have already discussed about what is AI and then what are the different parameters for an intelligent agent and the association of agent and the environment. If you haven't viewed these particular videos, please go through them. Today we are going to discuss about the third topic, that is the problem solving for the AI domain. So let's start today. So the problem solving. If there is some problem, how AI going to deal with that problem? That is the topic. So for that we have a particular type of agents. Those agents are known as problem solving agents. These are basically a kind of goal based agents that finds sequences of actions that lead to desirable states. Here the algorithms are uninformed, and what is the difference between informed and uninformed, that will be discussed thoroughly. Just for this purpose, just understand these algorithms don't have any extra information, that is why they are known as uninformed. That is no information, that is no extra information about the problem other than the definition. So no extra information and no heuristic or rules. So what is the architecture of goal-based agent? This one. If you don't know the different types of agents and what does it mean for an agent to be a goal-based one, you must go through this particular lecture. This is the part 4 and 5th video of the AI lecture series, where we have talked about the different types of intelligent agents. So after this goal-based agents, what are the things that we need to assume about the problem environment? Here we have assumed, that is, these are the things that we have taken for granted. That is, the environment should to be static, observable, discrete and deterministic. Oh, you don't know about the meaning of these things? Then you need to refer to this one video, where we have talked about the different environmental characteristics. That is this video. Okay, so please go through this video, then come to this video. So what does it mean to be a static one? That is a plan, that is how to reach the goal state. As it's a goal based agent, the primary objective of the agent will reach the goal, so the plan remains the same, that is a static one over here. Then the observable, that is the agent knows the initial state. Discrete, agent can enumerate the choices. Deterministic, agent can plan a sequence of actions such that each will lead to an intermediate state, and there will be a specific intermediate state. There will be no uncertainty. That is why the environment is deterministic. And there is a certain number of choices. There are not infinite number of choices. That is the discrete. And the observable, we know which state we are currently. That is the observable. And the plan is static. So that is the environmental characteristics, the first one. Okay. So then the agent carries out its plans with its eyes closed. Okay. So it's not taking into other information, right? We have already told it is for the uninformed, right? Uninformed algorithm. So agent carries out its plans with the eyes closed, certain of what's going on. It knows what is going on, and it's an open loop system. Now these type of problems are known as well-defined problem. Why a well-defined problem? That is, the problem should have an initial state, it should have the actions and the successor function, it should have a goal test. We need to test every time whether we have reached the goal or not, and there should be a specific path cost to reach the goal. So that is the well-defined problem. For these well-defined problems, we are going to search for the solutions. So just this particular figure, you are going to get the idea of the goal-based agent. This figure has been taken from the book by Russell and Norvig. The name of the book is Artificial Intelligence, a Modern Approach. If you haven't read this particular book, I will certainly recommend you to read this book. This is a very good book on AI. So, what is there in the book? In the book, it has been told that suppose you are in the Arad, this particular city you are in. Okay, so this is basically the map of the Romania, one particular country in the world, that is the Romania. In that particular country, these are the different city names. Now you are in holiday, suppose in Romania, you are in Arad and you don't have the Google map with you. You have to reach this particular city, that is Bucharest. So you need to formulate a goal to be in Bucharest. And how? That is the today's topic. So what you need to know? You need to formulate the problem. What are the problem will be there? There will be the states. And here the states are the various cities in which particular city you are currently in. So that is the states. Then the actions, that is you need to drive between the cities. That is the action. You need to find the solution, and the solution will be the sequence of cities. Right? Just see, you are in Arad, you can go to CBU, then you can go to Fargaras, then you can go to Bucharest. So this could be the way, that is the path that by which you can lead to the Bucharest. So that's the choice of the cities. You can go by this particular path, you can go by this particular path, you can go by this particular path. So there could be several paths. But what is your ideal choice of path? That is the path cost. That is, we need to minimize the path cost. That is the solution of the sequence of the cities. So if it is as it's a single state problem formulation, why single state? Currently we can be only at one particular state. Suppose you are in this particular city, any city, you can just suppose you are in Timisoara. So if you are in Timisoara, you cannot be any other city. Right, you can be on one particular city at one particular time. So it's a single state. As why? The state is here, the cities. Right, so this is a single state problem. So what is the initial state? That is, currently we are in Arad. Then the actions or the successor function, that is the set of actions, state pairs. Suppose you need to go from Arad to Zerint, you need to represent by this way. Right, that is, this arrow means you are in Arad, you will going to Zerint, and this, then your next state will be Zerint. Next, the goal state. It could be represented by two ways. One is the explicit way, one is the implicit way. Explicit way of represented is that explicitly you need to be at Bucharest, then only you can say you have reached your goal state. That is the explicit way. But suppose you are playing the chess. In the chess game, is there any explicit way of saying checkmate? It could be done by several ways and numerous ways. In any type of fashion, the pieces of the chess could be there. You can do the checkmate to the opponent. So that is the implicit way of representing whether you have reached the goal state or not. That is the implicit way of goal testing. Next, the path cost. This is basically additive way. Why? The sum of distances, the number of actions executed. That is why added. Suppose you are in Aranth, then you need to go to CBU. So this path cost is 140. Next, from CBU you are going to Fargaras. So path cost, this particular path cost is 99. But to reach Fargaras from Arad, what is the path cost? 140 plus 99. So it's the addition way. So this is the step cost. We have always assumed that it should be at least greater than equal to 0. That is, if there are two cities, that is, suppose one city has two different names, you should be do that thing in such a fashion that is the different name has been justified in your algorithm. Right. So then that means that whenever you are saying that you are moving from one city, that means the another city should be at least, or it should be, the path cost should be at least greater than 0. That is, at least one path cost should be there. So that is the step cost. And the solution, that's the sequence of actions leading from the initial state to the goal state. Now, how to select the state space? In the real world, it is absurdly complex. State space must be abstracted for problem solving. Here the abstract are the state, that is the set of real states. Action are the complex combination of real actions. That is, if you are currently in Arad, you need to go to the Zerint. That means you need to represent a complex set of possible routes, detours, rest stops, etc. For guaranteed reliability, any real state in Arath must go to some real state in Zenith, right? And the solution, that is the set of real paths that are solutions to the real world. Each abstract action should be easier than the original problem. Now we have explained the thing in the CTO concept of the Romania. Now just look at this thing, that is the vacuum cleaner world. Oh, you don't know? Then I will refer to this particular video. We have talked about the vacuum cleaner world. So I am not going to repeat it, just look at the video. So here this could be the different states possible. This thing basically the dust, and this is your vacuum cleaner. So whether there is a dust is there, or whether is a vacuum cleaner position in that particular tile or not, that is going to give you these 8 possible states. Now from that 8 possible states, we need to draw the state space graph, right? So this particular figure is also taken from the book. Okay, the same book I have already mentioned. Now just see that how this state space is there. Very simple. So if the vacuum cleaner is in this particular left tile and we are giving it action of right movement, so that means vacuum cleaner position will be this, right? Now if it is in this right position, you are going to give it right action, that means it will be in the same tile, so there is the same state. So this is the loop is there. Now suppose in this particular state you are going to give the vacuum cleaner of the suck action, that is cleaning of the tile, so that is dust will be removed, right? So that is this movement. Similar way, so from here if it goes to the left, so this is will be the state. Similar way, these 8 states can be mapped to a state space graph. Now these states, what are the states actions, goal state and path cost here? We have already talked about for the Romania country, right? Now state for the vacuum cleaner world, that is whether integers are the dart and the robot location, whether there is a dart or not, and what is the robot location, that are the states. What are the actions, that is the left movement, right movement and the suck movement to clean the dust. What are the goal state, that is whether there is a dart present at all locations, yes or no. What are the path cost, that is each action is going to give you a path cost of 1. Now how to represent this all thing, we need a search tree, that is these are the basic search concepts, that is we need first a search tree. In a search tree there will be search nodes. If you are in one particular node, you need to expand to its children nodes, that is known as node expansion. And how this search strategy will go, that is from which node to go, that is the search strategy by which you are going to do the searching to reach the goal state from your current state. So this is the preliminary idea about well-defined problems and solutions. And for more details, you need to look to my next video. And till that amount of time, please do subscribe to my channel and happy studying.